Welcome back to the Cosmic Classroom. Let's now talk about novae and supernovae. There were quite a little bit of confusion about what's what, and so let me try to clarify to you the difference between novae and supernovae, and there are actually two kinds of supernovae. So let me start with novae and supernovae that are related to a white dwarf. Okay, so I mentioned before that if you just have a low mass star that dies, a white dwarf is left, and that white dwarf will cool down and die and become a black dwarf. Now, if the white dwarf has a companion, then life becomes much more interesting, right? If the white dwarf has a companion, it may even be able to come back to life. That's how important the companion is. So let's just imagine a white dwarf, this very dense and hot object, that happens to have a companion. And they are orbiting each other, Eventually, this companion will start the process of dying too. And all stars, when they start dying, they get bigger, right? They expand. So now imagine this white dwarf and a companion that it's expanding, getting bigger and bigger and bigger. Well, it is possible that the surface of the companion gets so close to the white dwarf that the white dwarf starts to steal matter from its companion. Okay, so there's this, in the matter that's around this, the second star that's dying, it's mostly what? Hydrogen, right? That's what's in stars. It's mostly hydrogen. So it's this fresh fuel falling into the white dwarf. So fuel starts to accumulate around this white dwarf, accumulate and accumulate until it achieves the temperature and density, the right temperature and the right density to ignite fusion. And just like with the helium flash, the fusion ignites really fast, ignites everywhere. So the star, for a little amount of time, becomes really bright because it's fusing all of this shell of hydrogen fresh around that it's sitting in its surface, and it burns really bright for a while. And then it uses this fuel and continues stealing matter from the companion. And it can continue doing that very often. So a white dwarf can become a nova many times. So it can become a nova 1, 2, 3, 4, 5, 6 times. While there is fresh hydrogen that it can steal from the companion, it will go nova. Now, eventually, one of two things will happen. Either all the mass from this companion will be used up, and then the star won't be nova anymore, and it will again become a black dwarf. Or this white dwarf will accumulate so much matter, will steal so much matter from the companion, that it will achieve this, this magic mass of 1.4 times the solar mass. When the mass is 1.4 times the solar mass, the electron degeneracy pressure cannot hold the gravitational collapse anymore. The star explodes in what's called a supernova type 1. There's nothing left in this kind of supernova. No black hole, no neutron star. There's nothing left. Everything becomes dust all around. Okay? So material is ejected all around. And this is called supernova type 1, which is kind of funny because, after all, it has two stars, but it's called supernova type 1. Now, so I told you about nova and supernova. There is another kind of supernova, which is a supernova that's formed when a high mass star is in the process of dying. So a high mass star has all these shells here that were undergoing fusion, and eventually you have this core of iron that's held by now neutron degeneracy pressure that can't fuse anymore, it can't be held, so the star explodes. The explosion in this case may result in either a neutron star or a black hole. And what will happen will depend on the mass. If the mass of the star At the end, if the mass of this core of iron is more than 3 times the mass of the sun, it will collapse into a black hole. If it's less than that of the core, not the whole star, it will become a neutron star. And in here on the side of this slide, so we have the structure of this massive star supernova, sometimes also referred to as core supernova, core collapse supernova. And here is a little movie that keeps going on, showing the view from a planet when a star is going supernova. So it's going supernova, in this case it's becoming a pulsar. So you see the jets of the pulsar right there. And it keeps going on and on. So this supernova are referred to as supernova type 2. So one star, but supernova type 2. But there is also supernova type 1b and 1c. Those are all core collapse massive star supernova. And the difference between 1b, 1c, and type 2, I'm not going to go in detail now. It has to do with the composition of the star around it, and the lines that then appear when the spectral lines that can then be observed when the star explodes. So I hope you now know the difference between nova, supernova, that comes from a white dwarf, that needs to be in a binary system, and supernova from a massive star or core collapse supernova. I hope it helped. See you next time.